This is lesson 2 from section 4.1. Please make sure you watch the first video first before you watch the second video. Today, as an extension of what we learned on Friday, we're going to learn a different method of division that is called synthetic division. Let's first be reminded of what it looks like for long division. The denominator is your divisor that goes on the outside. We put our numerator underneath of the of the division symbol. Now we're going to divide one at a time. So we're going to divide x into x cubed. That goes x squared times. Then we multiply that x squared by what's on the outside, lining it up with the powers. Then we subtract. And we drop down the next term, and we repeat that process. So we're dividing x into x squared. That goes x times. Then we multiply that by the divisor out front, and we subtract. Then you drop down the next term. X goes into negative 6x, negative 6 times. And we multiply. And we subtract. This one gives us a remainder of 0. So the answer, using long division, is x squared plus x minus 6. Let's look at this new method of division that's called synthetic division. We're going to, instead of using the divisor, we're going to take the 0 of the function. That's going to be what would make x plus 2 equal to 0. So that 0 goes in the upper left-hand corner. Now, instead of writing out the whole polynomial, we're just going to take the coefficients in front. So it's 1, negative 3, negative 4, and 12. For synthetic division, you always drop down the first number. Now we're going to multiply the negative 2 by the 1, and that goes in the next open spot. Then we add. We're always going to multiply the 0 by the value that's left over, and then that slides to the next open spot. Then we add. Again, we're repeating that process, multiplying the 0 by that remainder and sliding that into the next open spot. Now, in order to use synthetic division, we have to watch our patterns. We noticed that when we took a cubic function and divided by a linear function, 3 divided by 1 is going to give me a quadratic. So this doesn't give me the variables for the x, so I have to add them in. This only is the coefficients. So I'm going to add those in, x squared plus x minus 6. And we can see that we got the same answer, whether we use long division or synthetic division. Again, notice that those values on the diagonals match those values that were down below. We get that same process, the same procedure. It just allows us to do so with a simpler version. Let's look at a second example. Again, we want to make sure that our numerator is in standard polynomial form. That is always a must. So we're going to take not the divisor, but the 0 of the divisor, which is negative 5. Then we're going to grab the coefficients. And we can begin our process of synthetic division. Always drop down your first term. Then we're going to multiply whatever is out front by that value we drop down, and that slides to the next open spot. Then we add. We multiply, slides to the next open spot. We add, we multiply, slides to the next open spot. We add, we multiply, slides to the next open spot, and then we add. Again, recognizing our patterns, we started with a 4th degree function, divided it or decreased that power by 1, so the result is going to be cubic. So we take these coefficients and we add in the variables. This is 1x cubed minus 2x squared plus 2x minus 5. Notice we ran out of terms, so that last term is your remainder. We write that as a fraction of our original divisor. Let's look at a couple more examples. Again, we don't take the divisor, we take the 0 of the divisor. We take our coefficients. We always drop down the first term. Now we're always multiplying and then adding. Everything gets multiplied, slides to the next open spot. So we're multiplying the negative 4 times 3, which is negative 12. And we're going to add it to the 14. Then we're going to multiply. We're going to add. We're going to multiply. And we're going to add. Again, looking at our degrees, cubic reduces it by a linear, gives me a quadratic. So when we add in our x's, 3x squared plus 2x minus 10. That last value is your remainder, and you write it as a fraction of your divisor. Really important on this next example that we check to make sure it's in standard polynomial form. Notice that we have a 4th degree function, a cubic function. We're missing that quadratic term. So we have to add our placeholder for that quadratic term as we're grabbing those coefficients. So it's 1, 3, 0, negative 16, negative 8. Drop down the first term. And from here we're multiplying. So we're multiplying the 2 times the 1. That slides to the next open spot. And then we add. We multiply. We add. We multiply. We add. We multiply. We add. Again, 4th degree, reduced by linear, gives me a cubic. We go start with the first term and add in our variables. So this is x cubed plus 5x squared plus 10x plus 4. Since there's a remainder of 0, we stop there. Here are 2 examples. I would ask you guys to again pause the video, try these 2 on your own. Again, make sure the equation or the expression is in standard polynomial form and that you're adding placeholders if necessary. As you guys unpause the video, you'll see the 2 examples here. Again, make sure that your equations start in standard polynomial form. Take your time so that you watch your signs, and then you decrease by 1. This process cannot be used if you are dividing by anything greater than a linear term. So you have to use long division when you divide by your quadratic. Example. This first one had a remainder of 3. That means x minus 2 is not a factor of this 4th degree function. When we look at this second example, again, x plus 2 had a remainder of negative 8, so it is not a factor of the function. Okay. The last thing we're going to talk about today is the factor theorem. Factor theorem is saying if the result of the division has a remainder of 0, then that divisor is a factor of the polynomial. If it has a remainder that is not 0, then it is not divisible. So as we go back to our previous one, let's look at a couple more. Again, we want to use synthetic division because it's going to be the fastest to be able to find our factors. So we want to see if x minus 2 is a factor of this 4th degree function. The 0 for x minus 2 is 2, so we're going to use synthetic division with 2. And we're looking for a remainder of 0 to be able to say yes. Again, we always drop down that first term. And now let's go ahead and multiply. Moves to the next open spot, and we add. We multiply. We add. We multiply. We add. We multiply. We add. Since the remainder is 0, x minus 2 is a factor of the function. Let's look at the second one. The factor is x plus 1, which means the 0 is negative 1. Now let's check. So we're going to multiply, add, multiply, add, multiply, add, multiply, add. Since the remainder is negative 60, that is not a factor of the function. Let's look at one more example. Again, we have the factor 3x minus 2, which means the 0 is 2/3. Multiply 2/3 times 3 gives us 2. Add those together. Multiply. Again, as we multiply, we're multiplying two-thirds by negative 21. 3 divides into 21 7 times, so that gives us negative 14. Add that together. Again, as we take that next product, we're multiplying 2/3 times 18. 18 divides into 3 6 times. 6 times 2 is 12. Gives us a remainder of 0. Since it has a remainder of 0, 2/3 is a 0 of the function, and the factor is 3x minus 2.